The last of our methods for solving quadratics comes with the quadratic formula. For a lot of quadratics, factoring might be pretty simple or straightforward, but sometimes factoring is either too difficult or it cannot be factored at all. Quadratic formula gives us a way around that. A lot of students like to default to the quadratic formula, but I do want to discourage using it for every type of quadratic because it can often become cumbersome and take longer than it needs to be, especially for quadratics that are easily factorable, especially if the leading coefficient is 1. So I want to encourage you to always be able to evaluate quickly whether or not you can factor or if the quadratic formula is necessary. There's also a part of the quadratic formula that allows us to evaluate pretty quickly whether or not something is factorable, and that would always encourage you to do that as a method. So given the quadratic formula, where x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a, as long as our quadratic is in standard form, we can substitute the values in for the coefficients and the constant and solve for x. And just like with our other methods, most of the time we're going to get two solutions. So taking a look at our first quadratic, it's not in standard form. So we'll go ahead and we will subtract 9 to get it in standard form. Our values for a is 1, b is negative 6, and c is negative 9. So we can substitute it into our quadratic formula. X equals negative b plus minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Now, oftentimes when we have quadratics and we have to use the quadratic formula, we have irrational solutions. So evaluating the whole thing in your calculator may not give you the result that you want. So it's always a good idea to look at it piecemeal. Starting with the part on the inside, we can evaluate this entire expression. We can also apply our double negative rule, and we can multiply a times 2. So we can simplify the expression as 6 plus or minus the square root. That entire thing evaluates to 72 divided by 2. Now, since we can't square root 72, we need to simplify it. So we need to find factors of 72, preferably the largest one that can be square rooted. So if we divide 72 by 2, we find that the other factor is 36. So we can rewrite our quadratic equation as 6 plus and minus the square root of 36 times the square root of 2. We've taken the square root of 72 and broken it apart into the product of two radicals. And all that over 2. So then we can actually square root 36. So 6 plus and minus 6 square root of 2 over 2. And then to simplify it, we look to see if the following factors here, here, and here, or the following terms, have a common factor. They all have a common factor of 3, so we can divide, of 2. We can divide each of those by 2, leaving us with 3 plus and minus 3 square root of 2 divided by 1. And since it's a denominator of 1, we don't need to keep it. So there is our solution. And again, because of the plus and minus, we have two solutions, 3 plus 3 root 2 and 3 minus 3 root 2. Notice how the 2 was not included in the simplification for the 2 inside the radical, only the coefficient on the outside. So be aware when you're factoring of that, or simplifying of that case. Go ahead and do it again. This is already in standard form, so we have a equals negative 3, b equals 12, c equals 4. So we'll substitute into our quadratic equation. We'll simplify. We can simplify our radical. We look at 192. If we divide it by 2, we get 96. Neither of those are perfect squares, so let's try something else. Let's divide it by 3, and we get 64. 64 is a perfect square, so we can rewrite this as negative 12 plus and minus the square root of 64 times the square root of 3 over negative 6. And then we can simplify. Here we have a negative divided by a negative, so that cancels out with our double negative property. And then all of these have a common factor of 2. So we end up with 6 plus and minus 4 root 3 over 3. That's as one fraction. Alternatively, we notice that these two parts do continue to have a common factor, so if we want to try and simplify that more, then we have to rewrite this as two separate fractions, where we have 4 root 3 over 3 as well as 6 over 3. So we use the same denominator and just split the numerator into two terms, and then we can simplify 6 over 3 as 2. Either of these answers were acceptable. They are equivalent, so when you're dealing with multiple choice, you may just need to keep an eye out on which form your solution might be in.